Find the magnitude and direction angles, alpha, beta, and gamma, for the resultant force. We see in the figure there is a system of two forces. Force B acts on line AB, and force C acts on line AC. I have my engineering paper set up with the given and find information. The first thing I need to do is find the XYZ coordinates of the 3 points. I'm going to use them to formulate my force vectors. I find the coordinates for point A based on the dimensions shown. A is in the YZ plane, so there's no X dimension, and Y is 2 meters, Z is 5 meters. Point B is at the origin of the axes, so its XYZ coordinates are all 0. Point C is in the XY plane, 3 meters in the X direction and 6 meters in the Y. If I think ahead, the easiest way to find the resultant force of a system of vectors is to write the original vectors in Cartesian notation, then add the components. So I need to put my vectors B and C in Cartesian notation. I'm going to start with vector f sub b going from A towards B. What I need is a unit vector acting from A towards B. I'm going to find it by first creating a position vector based on the coordinates of points A and B. I find the position vector by taking the coordinates of the endpoint and subtracting the corresponding coordinates of the start point. In this case, our endpoint is point B, and our start point is point A. Here is our position vector. I can convert the position vector into a unit vector by dividing the position vector by its magnitude. The magnitude comes out to be the square root of 29, so I'll divide the 3 terms by the square root of 29. And now I have a unit vector pointing from A towards B, and I can verify it's a unit vector by taking the square root of the sum of the squares of each of the 3 terms, and it will equal 1. I can now find my force vector FB by multiplying the magnitude of the force by my unit vector. FB has a magnitude of 750 newtons. And here's my force vector FB in Cartesian notation. Let's do the same now for force vector FC. Force FC goes from point A towards point C, so I'll first find its position vector using the coordinates of point C and point A. Here's my position vector. I can convert it into a unit vector by dividing by its magnitude, and then I can convert that into the force vector FC by multiplying it by the magnitude of the force, which is 600 newtons. I'm going to do that in one step. The magnitude of my position vector comes out to be the square root of 50. And here's my force vector C in Cartesian notation. I can now get my resultant force by adding force vector B to force vector C. I do that by adding the I, J, and K terms from my 2 forces. I can now find my resultant force magnitude by using the Pythagorean theorem and the 3 terms I just found. I now have my first answer. Now what I need to find is my alpha, beta, and gamma terms, and then I'm done. The cosine of alpha is the x component over the magnitude. Beta is the y component over the magnitude, and the cosine of gamma is the z component over the magnitude. And now I'm going to take the inverse cosine of each of these fractions. Now I have alpha, beta, and gamma. And we're done.